Hello again, everyone. So we're going to do one last review of how to add vectors graphically. So I'm just going to talk you through generally how to do this, but it's kind of your responsibility to go back in the book, look at the examples, because the examples have everything you'll need to work through it. I'm just going to talk you through generally how you would get to an answer. So say we have two vectors. We'll call the blue one vector A, the green one vector B. And so in order to solve this, we need to break them up into their x and y components. Now the good news is that in your problem they'll start like this. We got right angle for B, right angle for A. So they're already in their x and y components in this case. So your end result's going to be, as we know, you put the tail of one at the tip of the other, and you get the resulting vector looks something like that. But mathematically, how you're going to do it, just to review, in this case we can skip the sine and cosine part, but I'll come back to that later. So we have A and B. So our goal is to find this angle right here that goes all the way from the first quadrant, because that's how we do our reference angles. And so in order to do this, we have our magnitude A is in the x direction, B is all that's going to be in the y direction. So in order to find the angle, we use our tangent inverse function, and it's going to always be, you have your y over your x, and that's going to equal your resulting angle here. But in our case, since we have them labeled A and B, in this case our A is our x, our y is our b, and then we'll get some degrees C. Not to be confused with degrees Celsius, this is something different. But here, so what we're going to do is, this will give us some number. But if we look at, we have quadrant 1, 2, 3, and 4. If it's in quadrant 1, we do nothing. If it's in quadrant 2, we take the number and then we add 180 degrees to it. If it's in quadrant 3, we also add 180 degrees to it. But if it's in quadrant 4, this is where it gets a little tricky, we add 360 degrees. Now this is just because sine and cosine work between 0 and 90. So this is just a correction factor to get the angle adjustment. And so once you do that, you should get your final resulting angle. And now we need to find the magnitude. So let's just create a little more space here. So in this case, our final answer would be C plus 180 degrees, because it's in quadrant number 3. But now we need to find out what magnitude this resulting vector C will be. And we get that from the Pythagorean theorem. So that's where we have our a squared plus b squared equals our c squared. So in order to get c by itself, you'll have a squared plus b squared, and then you'll take the square root of both of those, and that will get you your c value, which is your magnitude. So you have your degrees from the tangent inverse, your magnitude from the Pythagorean theorem. Okay, now let's erase this and do if we need to find our x and y's. We're going to do this general again. If you want some specific examples, look at the examples in the book. So, we're going to take our blue vector and put it at some angle. Let's see, let's go, we'll call this 25 degrees for our blue arrow. And then let's say we want to add it to our green arrow. Let's do this at 110 degrees. And I'm not going to solve this for you. I'll let you work through it, and I'll put the answer in the little description area on the YouTube channel. And so here's what we're going to do. Let's see. So this looks about roughly twice the size of this vector. So we'll call the blue one 15 meters per second. And the green one we're going to call 8 meters per second. And now what we're going to do is we're going to find the x and y components of each of these vectors. So over here we're going to work through the green arrow, and down here we'll work through the blue to get the x and y components of the vector. So in order to do that, let's start with the blue vector here. And so the result for, let's start with the x, which is going to be along the x-axis here. We're going to get the x vector, the x component, and our x, I said blue, right? So we need to do that on the blue area. So our x, x of blue, is going to equal 15 times the cosine of 25 degrees. And that will get you your x value. Then your y value for b is going to be this vector right here. And y of blue is going to equal 15 times sine of 25 degrees. Now remember, sine is going to be your y, cosine is going to be your x in all cases during this first test. So that's easy, you can remember that. So fairly simple, two equations to find the x and y. Now let's do the same thing for green. Now I can draw my x here, xg for green, and that is going to equal 8. As we can see, that's our magnitude. And for our x direction, which is going to be here, that is going to equal, once again, the cosine of our angle of 110 degrees. 110 degrees measures from this angle here, our vector, all the way to our starting point, which is the positive x-axis. And so we're going to do cosine of 110 degrees. And then what we're going to do is find our y of the green. So our y of the green is going to be 8 times sine of 110 degrees. Now remember, this is 8 meters per second. Do not forget to put your units back at the end of this problem. But now we'll have our x components for blue and green, and our y components of green and blue. And now we're going to add those together to get some resulting vector. If you remember graphically, we just take one of them, put tail to tip. We should expect some vector in this direction here. So if we do that, we're going to, in general form, once again, we're going to do it as we're going to add our x's together. So we got xg plus xb. Now remember, if they're negative, it could be that it looks like you're subtracting, but you always add. So x of g could be a negative number, but you still add that, which may result in a subtraction. But that is going to give us some x total, x of t for total. Then we're going to do the same thing for our y's. We have y of green plus y of blue, and that's going to give us some y total. And once you have your x totals, your y totals, you're going to find your magnitude and angles. So let's start with the magnitude this time. So it looks like if we put the green on the blue up here in the corner, it looks like our vector is going to be just a little bit longer than our blue vector. So your answer should be somewhere a little bit higher than the 15 meters per second that describes our blue. But you'll see the answer in the comments. Hopefully you didn't peek too soon. So let's see. We're going to have to get our resulting magnitude, and magnitude we'll call m. Our magnitude of resulting vector is going to be xt squared plus yt squared, and that whole thing square rooted will give us some magnitude. Good old Pythagorean theorem once again, nothing new. And now for our angle, we're going to do, let's call our angle, for those of you in Greek, we'll use theta. That's a common Greek letter used to denote this. So our theta is going to equal tangent inverse of our y and our x. So we have our, it's y over x, so your y total over your x total, and that will give you some angle. Now good news. Let's look back at our resulting vector where we expect it to be. We expect it to be in the first quadrant here. So you should get some angle that's going to be less than 90, greater than 45 most likely. That's how you know you're in the right range. And since we're in the first quadrant, that means we do not have to use a correction factor. We do not need to add 180 if it was in 2, 180 if it was in 3, or 360 if it was in 4. Since it's in the first quadrant, number 1 here, we can leave it how it is, and that's our answer. So, I hope this is useful. Basically, you work through the steps. If you work through the steps, you should be fine. First, find your x and y's of vector 1 and your x and y's of vector 2. Add them together, and then find your magnitude and your angle. So let's see. We got here step number 1. Good old step number 1. Find your x and y's. Once again, over here we have our x and y's. This is still step number 1. So you do step number 1 for each vector. And now once you have common components, go over here, step number 2. You add your x and y's together. Now 3 or 4, you can do this in either order. Then you find your magnitude. That is number 3. And then you find your angle, theta, down here. That is number 4. And then if you really want to, you can do step number 5. And we got step number 5 here. Graphically add your vectors. Make sure what you get from the math makes sense. I hope this was helpful. Good luck on your test.